Greetings, Mrs. Shapiro here. Let's learn how to factor a difference of two squares. What I'm going to start off with is a multiplication problem first. And I want you to notice we have the same first term, x, and then we have the same second term, 3, but one's a plus and one's a minus. And look what happens when we multiply this. X times x is x squared. X times negative 3, negative 3x, 3 times x, positive 3x, and 3 times negative 3, negative 9. These are both x's, so we can combine those like terms. We have x squared, a negative 3x, and a positive 3x is 0, so that cancels, and we have a negative 9. So this is what happens anytime we have the same numbers in the factor and one's a plus and one's a minus. So that's going to help us figure out how to factor here. When we have m squared minus 9, so this is a number squared and 9 is 3 squared. So we're going to factor this, an m and an m, a 3 and a 3, and one is a plus and one is a minus. So our factoring is m plus 3 times m minus 3. It doesn't matter if the first one's a plus or the second one's the plus. One factor has to be m plus 3, one has to be m minus 3. All right, let's look at this next one. We have a squared, and what number squared is 49? Are you thinking? 7 squared? That's right. So when we factor this, we need an a times a 7 times 7, one's a plus, one's a minus. Again, if we check this, a times a is a squared, a positive 7a, a negative 7a, that adds to 0, and a negative 7 times a positive 7 is negative 49. Okay? What number squared is 25? Did you get 5? That's right. So we have a b and a b, a 5 and a 5. One's a plus, one's a minus. What number squared is 64? So again, obviously, this only works with perfect squares. So 64 is 8 squared. So we'll have r and an 8, r and an 8. One's a plus, one's a minus. And again, doesn't matter if the first one's a plus or the first one's a minus. One factor has to be r plus 8, one factor has to be r minus 8. Okay? Now, we can have these perfect squares at the front also. So 9 is 3 squared, x squared. And what number squared is 16? Right, 4 squared. And so our factoring's going to be a 3x and a 3x, a 4 and a 4, one's a plus, one's a minus. Next one, similar type, perfect square in front and in the back. So what number squared is 81? Right, 9 squared, x squared, and this is 2 squared. So our factoring's going to be a 9x and a 9x, a 2 and a 2, one's a plus, one's a minus. Are you having fun yet? I am. All right, let's look at 2 more problems just like that. Perfect square in the front, 2 squared, a squared. Perfect square in the back, 3 squared. And our factoring is just going to be a 2a and a 3, a 2a and a 3, one's a plus, one's a minus. Again, if we check this, 2a times 2a is 4a squared. 2a times 3 is 6a. Negative 3 times 2a is negative 6a, so they add to 0. And then what's left is negative 3 times positive 3. That's negative 9. Okay. 36 6 squared, a squared. We haven't run into this yet. What number squared is 1? And ding, 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 you're right, it's 1. So our factoring is going to be a 6a and a 1, 6a and a 1, 1's a plus, 1's a minus. Okay. Now, we can also have a difference of 2 squares, but it's not obvious first. So when we have a problem like this, it's 2 parts long, so it could be a difference of 2 squares, but let's see, is there a common factor here? And yes, there is. There's a common factor of 2. So when we take out that common factor of 2, we get this, and ta-da, a difference of 2 squares. So we bring down our 2, x squared is xx, 25 is 5 squared, 1's a plus, 1's a minus. So this whole thing is our answer. What common factor do you see here? What number is a factor of 3 and 27? And if you guess 3, that is correct. So if we take a common factor out of these, we'll get an a squared minus 9, and then bring down the 3, and this is a squared, and 9 is 3 squared. So we're going to have an a and a 3, a and a 3, 1's a plus, 1's a minus. Okay, so again, doesn't look like a difference of 2 squares, but if we take out a common factor of 2, then what's in here is actually a difference of 2 squares. So bring down the common factor of 2, x times x, and what number squared is 36? Did you get 6? That's right, and 1's a plus and 1's a minus. And again, this whole thing is our answer. All right, the last thing I want to show you is problems that have 2 variables. Okay, and so there's no common factor here, but we have m squared and n squared. So m times n times n, 1's a plus, 1's a minus. Okay. Here we have 2 squared, r squared, 5 squared, s squared. So our factoring is going to be a 2r and a 5s. Again, 1's a plus, 1's a minus. Okay. Let's look at this one. First, there's a common factor of 7. So we'll take that out, and we get b squared minus 4c squared. And now we have a difference of 2 squares. We have b squared, b times b is b squared. 2c times 2c is 4c squared. 1's a plus, 1's a minus. Okay. I hope I've given you enough examples. You can give me some feedback on my video. It's a little long. I see it's 8 minutes, but I think we went over quite a few problems. All right, good luck with this. Hugs and kisses from Mrs. Shapiro.